In 1929, the London Power Company commissioned a power station on the south bank of the River Thames that would become one of the most recognizable industrial buildings in the world. Battersea Power Station was designed with brick walls 6 feet thick, although 3 feet would have been structurally sufficient. The exterior was faced with specially molded bricks selected for appearance rather than durability. The steel frame supporting the building could have stood with minimal cladding. However, the architect Giles Gilbert Scott insisted upon mass and permanence on every surface. Critics described it as architectural ostentation for a purely functional industrial building. The station operated for 50 years, then stood abandoned for 30. When redevelopment finally began in the 2010s, every proposal retained the brick shell, not because regulations required it, but because nothing could replace what Scott had built. The walls Battersea did not need ultimately became the only thing that truly mattered at Battersea. In the 1920s, electricity demand in London rose unpredictably alongside a growing population. The population had reached 7 million. Factories, underground railways, street lighting and domestic consumption made energy indispensable. Existing generating stations scattered across the city were inefficient and outdated. The London Power Company required a vast new facility capable of producing electricity on an unprecedented scale. The selected site was a 9-acre plot on the south bank of the Thames at Battersea, directly opposite Chelsea. The location offered several advantages: proximity to the river for cooling water, access to railway lines for coal deliveries, and distance from affluent residential districts that might object to industrial construction. As you continue watching this video, do not forget to click the subscribe button below, because this small action brings us happiness and allows us to continue producing this kind of content. A simple subscription shows that these words have reached you, so please like the video and subscribe to the channel. The initial design for the station was entirely functional. Engineers proposed a simple steel-framed shed, clad in corrugated metal, standard practice for industrial buildings of the period. Cost estimates minimized aesthetic considerations. Then the London Power Company made an unusual decision. It hired Giles Gilbert Scott as consulting architect. Scott had designed Liverpool Cathedral and was known for prioritizing architectural dignity in all his work. He accepted the commission on one condition: he would have complete control over the exterior appearance. Engineers could design the machinery and the structure, but the building's public face would belong to him. Scott's vision transformed the station into a monument. He proposed a symmetrical Art Deco composition on both axes, with 4 chimneys emphasizing vertical lines and geometric forms. The chimneys would be white rather than the traditional industrial black, making them landmarks visible across London. The exterior would be entirely clad in brick, not ordinary engineering brick, but specially molded facing brick laid in Flemish bond. The walls would be thick enough to bear structural loads, even though the internal steel frame did not require it. Scott argued that a power station serving millions of Londoners should not be concealed. It should be beautiful. The engineers resisted. The additional cost for a building the public would never enter seemed unjustifiable. Scott prevailed. Construction began in 1929 with Station A, the western half of the complex. The steel frame rose first. Enormous columns and beams designed to carry the weight of turbine halls, boiler houses, and coal handling equipment. Once the frame reached full height, brick cladding commenced. The specification called for specially manufactured bricks of defined dimensions and color. Each brick measured 9 inches in length, 4.5 inches in width, and 3 inches in height, larger than standard, reducing the number of joints and increasing resistance to weathering. The color was specified as warm beige, in keeping with Scott's preference for materials that aged gracefully. More than 6 million bricks were used in Station A alone. The walls were built 6 feet thick at the base, tapering to 4 feet at roof level. Structural calculations demonstrated that the steel frame could carry all loads without assistance from the brick cladding. The walls were not load-bearing. They functioned purely as enclosure and appearance. Yet Scott specified far greater thickness than required for weather protection. The standard single-skin brick with cavity wall system of the time would have provided adequate insulation and rain resistance at far lower cost. Instead, Scott built mass. The justification was aesthetic and symbolic rather than engineering-driven. A station generating electricity for 7 million people should appear permanent. Thin walls would look fragile. Thick walls conveyed strength and reliability. Bricklaying proceeded by traditional methods. Craftsmen worked from timber scaffolding, laying each course by hand in lime mortar. The Flemish bond pattern, alternating headers and stretchers in every course, created visual texture and distributed stresses evenly. Expansion joints were inserted at regular intervals to accommodate thermal movement caused by heat generated within. Windows were recessed deep into the thickness of the walls, forming pronounced reveals that emphasized mass. Detailing was meticulous. Every corner, opening and transition carefully resolved. This was not ordinary industrial construction. This was architecture applied to industry. Station A entered service in 1933. 4 boilers fed two 69-megawatt turbo alternators, producing a total of 138 megawatts, sufficient to supply a substantial portion of South London. The 2 chimneys, each 337 feet high, became instant landmarks. Their white cladding made them visible for miles, particularly at night when the facades were illuminated by floodlights. Public reaction was mixed. Some praised the grandeur of the building and the civic pride it represented. Others criticized it as unnecessary extravagance during economic depression. Architectural journals debated whether industrial buildings should pursue beauty or function alone. Scott ignored the criticism. He had achieved his aim, a power station that did not apologize for existing and appeared to belong. The success of Station A led immediately to plans for Station B, the eastern half, which would double capacity. Construction began in 1937, but was interrupted by the Second World War. Work resumed in 1944 and continued until 1955. When completed, Battersea Power Station had 4 chimneys arranged in a square, 8 boilers, and 4 105-megawatt turbo alternators, producing a total of 420 megawatts. It was the largest brick building in Europe and one of the most productive coal-fired power stations in the world. The total brick count exceeded 20 million. Walls that did not need to be thick, did not need to be beautiful, and did not need to exist structurally had become the defining feature of the building. The thickness of those walls served functions Scott may not have fully anticipated. Power stations generate immense heat. Boilers operate at temperatures exceeding 1,000 degrees Fahrenheit. Turbine halls experience constant thermal cycling as equipment starts and stops. Thin walls would have expanded and contracted significantly, creating stress fractures and requiring frequent maintenance. The 6-foot walls at Battersea acted as thermal mass, absorbing heat fluctuations and moderating temperature swings. The building maintained more stable internal conditions, reducing strain on equipment and improving operational efficiency. Similarly, the mass dampened vibration from turbines and generators. Thin walls would have transmitted noise to surrounding neighborhoods. Thick brick absorbed it. Residents nearby heard only a low hum rather than the mechanical roar expected from a facility producing hundreds of megawatts. Battersea operated continuously for 50 years, powering London through post-war reconstruction, expansion in the 1960s, and into the 1970s. Turbines turned day and night. Coal arrived by barge and rail. Millions of tons over decades. Ash and clinker were removed and disposed of. The chimneys released smoke that, despite filtration systems, contributed to London's notorious air pollution. By the late 1970s, environmental regulations tightened, and coal generation became uneconomic compared with newer gas and nuclear stations. Output declined. Station A was decommissioned in 1975. Station B closed in 1983. After 50 years of service, Battersea Power Station fell silent. The question then arose, what should be done with an abandoned power station occupying 9 valuable acres of riverside land in central London? The first obvious proposal was demolition. The steel frame and machinery had scrap value. The cleared site could be redeveloped for housing or commercial schemes. Yet demolishing Battersea proved more complicated than constructing it. The structure was listed Grade 2 in 1980 and granted legal protection. Any redevelopment had to retain the existing shell. Development teams struggled with these constraints and the building was too large to adapt easily. Interiors were designed for vast industrial equipment, not human occupation. The brick walls that had seemed excessive when built now appeared burdensome, expensive to maintain, impossible to remove, and lacking clear functional value in a post-industrial context. For 30 years, numerous redevelopment schemes were proposed but not realized. A theme park, a shopping center, luxury housing, office space, and various combinations. Each encountered the same problem. The power station's architecture was magnificent but inflexible. Turbine halls and boiler houses did not easily convert to modern uses. The brickwork required costly repairs after decades of neglect. Water had penetrated through damaged roofing, freeze-thaw cycles, cracked mortar joints. Steel reinforcement corroded in places. Yet, despite deterioration, the fundamental structure remained sound. The 6-foot walls had not collapsed, foundations had not settled, and the chimneys still stood upright. Thickness that appeared unnecessary in 1933 had become indispensable durability by 2003. The building's survival after 30 years of abandonment proved Scott's instinct correct. Thin walls would have failed. Weather, vandalism, and neglect would have destroyed anything built to minimum standards. Battersea's mass protected it. Rain penetrated only a few inches. Wind caused no structural movement. Even where sections of roof collapsed, the walls beneath remained intact. Comparison with other abandoned industrial buildings of the same era is instructive. Dozens of power stations, factories, and warehouses built in the 1930s were demolished once maintenance ceased because their structures deteriorated rapidly. Battersea deteriorated slowly. Thick walls bought time. Time for public opinion to shift, for preservation advocates to organize, and for economic conditions to make adaptive reuse financially viable. That viability arrived in 2012, when a Malaysian development consortium purchased the site and committed to comprehensive restoration and conversion. The project would retain the entire brick shell, restore the chimneys, and transform the interior into a mixed-use development of apartments, offices, shops, and public space. Costs exceeded £9 billion, making it one of the most expensive property projects in British history. Much of that expense went towards preserving and restoring Scott's brickwork. Every brick was inspected. Damaged sections were carefully dismantled, bricks cleaned and relaid. Those beyond repair were replaced with custom-manufactured units matching the original specification. Mortar was renewed using a lime-based mix consistent with the 1930s formula. Chimneys partially dismantled for safety were rebuilt faithful to original dimensions. The restoration revealed the quality of Scott's original construction. Despite 70 years of use and 30 of abandonment, the brickwork was fundamentally sound. The Flemish bond had distributed stresses evenly, preventing extensive cracking. Expansion joints had functioned as intended, accommodating movement without failure. Lime mortar, considered old-fashioned in the 1930s compared with Portland cement, had aged better, allowing moisture movement and repair without damaging bricks. Modern engineers judged the walls over-engineered by contemporary standards, yet perfectly calibrated for their actual lifespan. Without knowing it, Scott had built for a century. The adaptive reuse of Battersea Power Station opened to the public in phases between 2021 and 2022. Turbine halls became event spaces and retail areas. Boiler houses were converted into apartments and offices. The chimneys, no longer functional, remained as architectural features and symbols. The building now attracts millions of visitors annually, not to see industrial machinery, which no longer exists, but to experience architecture. The thick brick walls that appeared unnecessary in 1929, extravagant in 1933, and burdensome in 1983, are now the principal attraction. Developers market the site as living inside an icon. Residents pay premiums for apartments framed by 6-foot thick walls. The criticized mass has become the value proposition. Modern power stations bear no resemblance to Battersea. They are lightweight structures optimized for efficiency and cost. Machinery is enclosed by steel cladding or prefabricated concrete panels. Aesthetic consideration is minimal. Service life is calculated at 30 to 40 years, after which decommissioning and replacement with updated technology is expected. In an era where energy generation technology changes every decade, Building a station to last a century appears irrational. Yet when modern stations close, they are demolished immediately. They possess no architectural value worth preserving. They cannot be adapted to new uses. They are optimized for a single purpose and a single lifespan. Thereafter, they become waste. Battersea was not optimized. By the standards of 1929 and 2024 alike, it was over-designed, overbuilt, and over-specified. The brick walls had no structural function. They were far more expensive than necessary. They slowed construction at a time when mass production methods were expanding and required skilled craftsmanship. Every rational economic argument opposed them. Yet those walls are the reason Battersea exists today. Had Scott built a steel shed clad in corrugated metal, the building would have been demolished without debate in 1983. No one preserves functional sheds. No one adapts them to new uses. No one pays billions to restore them. Walls that did not need to exist became the only thing worth saving. The lesson Battersea offers is not that all buildings should be over-engineered. Most structures serve temporary needs and should be designed accordingly. However, certain buildings, those in prominent locations, serving public functions or representing civic ambition, benefit from construction beyond calculated necessity. Extra thickness that seems wasteful in year one, higher quality materials, and attention to detail become necessary in year 50 and invaluable in year 90. Scott understood this instinctively. He designed Battersea not for the 1930s, but to survive indefinitely. The engineers who opposed him were correct by the standards of their era. Scott was correct by the standards of time. Battersea Power Station stands today on the Thames. Its 4 white chimneys visible across London as Scott intended. The turbines are gone, the boilers are gone, the coal yards and ash disposal systems are gone. The machinery that justified the building's construction has entirely disappeared. What remains are the walls, 6 feet thick, 20 million bricks laid by hand in Flemish bond, built to no structural standard except permanence. The power station that did not need those walls has become walls that no longer need a power station. Scott's architectural excess is now architectural necessity. The critics who called it waste are forgotten, but still Battersea endures.